So I hope everybody can hear me. Hello, everyone. So I hope everyone can hear me. Can you all hear me? So we are about to start. Can you all hear me? Hello? So let's see. Now we are going to start from where we stopped the other time. As you can see, the other time we are able to look at source parameter imaging, where we used to find the depth. We're also going to look at Euler as well as the spectral analysis in order to carry out a depth, in order to compare all the three methods for the depth estimation. We have seen this, how to get the depth spectral, how to get use the source parameter. Now, let's first look at spectral and come back to Euler, compare the three. To do that, we go to our grids. We have the dx, dy, dz. What we have done under the SPI, there we need also this grid, residual. Now we're going to use the residual in order to carry out the spectral analysis. So let me see whether you have a question. So please, if you have a question, you can paste it there. And let's go ahead. Of course, this must have to be in meters, projected coordinate system before you carry it out. We have already bring out the ArcMap menu, or you can look under GX. You can look under GX. Look under GX. And from the GX, you can now bring in ArcMap. Of course, I have the ArcMap. ArcMap here is this. Go to iterative filter. First step 1, step 2, step 3, then step 4. It's just 4 steps. Prepare the grid. Here we input the grid, residual XY. So we have to move backward. We have to move backward and then we call it residual pre. Move to residual pre. Save. So you just have to add a pre. It's better to add a pre so that it will be easy to identify. This name should be different from this. Okay, so you can call it any name, but just add underscore pre so that it will be able to be captured. Then click start. Now it has done. Then the second step, iterative filtering forward, FFT. Now it has picked up the name, and which is where we save it before. So no need to change anything. Then okay. Then go back. The third step is radial average spectrum. This is the what we did in the previous one. No need to change. Then come. This is the output. Click on this three dot. Go back. Then call it any name. Can call it residual underscore spec. It's a spec file. So I'll call it S underscore this, just to give it a name. Then click OK. And now is to bring out that spec file to plot. Now go to under spectrum calculation and display. There we'll click on display spectrum. There it has picked it up. There we'll click OK. Now there we'll click on this. This is the spectral analysis for the whole grid. Will give us the average depth to deeper sources as well as shallow sources. So let's see whether somebody have mistake. Okay. So now let's go back to this. So when we look at spectral, I'll zoom out. Use the space bar. You can see I have this curve. The curve starts like this, bends like this, then goes down. If you scroll up, you see this is the variation of the depth. It goes down, goes up to what? 60 meters. It goes up to 6 meters. Then you have this, you have this, you have the rest, and the rest. All these parts are all noises. This is the depth in kilometers, 0 up to 8, can goes up to 6, and some of them are around 2 kilometers. You can see all these signals are all below 2 kilometers. So definitely this might be deeper sources. So we can find the depth here right inside this using this. So we have two data we have to look for very well. First of all, this segment. I want to split this line into 3. This segment is 1. If you draw a straight line to this part, the line will look like this. This part will look like this. The whole of this may just be 1. So for us to be able to draw those lines on the spectral analysis, all we need to do is to just go to this map, then double click outside. Then you go to the menu bars. Now it's being activated. Then click on draw a straight line. Then click and drag. Don't worry, we can position it later, like so. Let it go. Then you take the other part somewhere like this. This will give you this. Then you see the whole of this other part might just be the noises. So let's say you want to position, then you click first on this, then you click on this. Now you want to realign it. What you know, you just right click on this point. In case you want to position very well, then you click on edit vertices. Then now you can move this point. You can align it like so, the way you want it. So roughly this way. There, from there, we right click, end group editing, and double click again. Select the next one, right click, attribute, not attribute, right click, edit vertices, so that we can position the way we want it. Like so. Then right click on this one, end group editing, double click, and now select this first one, and right click here, then go to attribute, change this width to 6, change the draw color to red. You can choose any color. I prefer to go with this color, and click the next, right click, attribute, change this to 6, and this to blue, and okay. Then from there, you now okay, so the next is to go and now write the text. Double click on this, now write depth to deeper sources is equals to dash dash kilometer. We'll come back to edit it. Then you go change this around to 3, change this to bold, then change the color to red, then okay. Click OK, then click back on this, click on this, you position it, then click on this, click outside, do the same thing. Depth to shallow sources is equals to dash dash kilometer. Then we have this, change the color to blue, then we are good to go. Okay. Okay, then click back on this. Don't forget to click back on this to select it, then position it. And now zoom out a bit, then click outside. Now we have this. This now is the deeper. All these other parts are just the noise. Around, you can see these are all noises. The depth are roughly less than 1 kilometer. How do you get this one? To get this slope, all we need to do is to get the slope, also get the slope. So I have an Excel file I've created, spectral analysis result. For deeper sources, I need to get 2 points, x1, y1, x2, y2. Del x, that is, what is del x? This value minus this. Del y, this value minus this. The slope, of course, is this divided by this. The same thing here for shallow sources. Then I know from spectral analysis, the depth for each line segment is equals to minus the slope divided by 4 pi. The answer will be in kilometers. So whatever depth we get here to be in kilometers, if you like, you can change it to meters, change it to meters. So let's see how do we get this x1, x2, and the rest. So please, if there is a question of if you have any problem to ask, so you can go forward to ask. Okay, so any question? Let's first try to finish this spectral. Then I want to go, because it's good for you to do it without doing in Excel. This one is just to use to calculate the slope. That's all. Nothing much. How do you get this x1, x2? I want you to pay attention on the status bar where the mouse is. Look at where the mouse is moving. Down here, this is what you want to put your attention to. There are two values here, the first and the second. And now we click back on this shadow cursor tool. All right, then you right click anywhere. Or you can go on the map, you say right click. Inside the map, right click. There's views, you change this to data. When you change it to data, if you bring your mouse pointer to around this 5, if I look down here on the status bar, you can see the values changes. Is the second value is on the vertical. The first value is a horizontal value, which is in wave number. So when I position around here, you see the wave number is around this 0. You can see the values 0.5, around 1, around 1.5, around 2. So all I need to do, let me zoom out. What I will do, you position your pointer here on one of the line where the cross is the center. That's where you are. Then use your biro, your pen. Use your pen and write the values you see down. The value you see down is now 0.0003390. That is the horizontal. The vertical is 7.868. That is the first value. For the deeper, then move down or any point on the line, that red, where the pointer, the cross intersects. And the second value, you have 0.0815, comma 2.808. So this is what you have. Then that is for the deeper one. So go to the shallow, the same thing, we'll position it here. Then we'll take the first value minus 0.0056 and 4.757. 4.757 and move it down to the next value. We have 0.3998, comma, we have 0.784. 0.784. So you have these two values. Then go back to Excel, we input. Now we are going to input the values here. The first value is 0.00390. Second X is 0.0815. Then Y1 is 7.868. The second one is 2.808. Of course, this is the slope. Now to get the depth, we say depth is equals to this value minus open bracket, the slope divide by open bracket 4 times pi. In Excel is this pi, close bracket, close bracket, close bracket, enter. You can see the depth is around 4 point something kilometers. You can change it to meters. So one can write this is the value we have. Control C, we'll copy it, we'll go to this. No, we'll go back, click back on this, double click outside. Click on this, double click, then now paste, Control V. You paste that value and change it to 4.64 meters. So this is the depth to the deeper sources, 4.96 kilometers. That is the depth. And the shallow, the same thing will do. Let me save. Now we have minus 0.0056. The second value is 0.3998. 0.3998. The first value is 4.757. 0.784. So this is what we have. Now this now is the slope. Then to get the depth, the same thing is equals to minus the slope divided by open bracket 4 times pi, open bracket, close bracket, and this is the depth of what we have. Control C, save, already saved. Then we'll Control C to copy it. Now go back to this, select this, double click, come to this point, and then paste. This will give you around 99 kilometers. So now this is what we have. Save, so you can see the average depth. So this is roughly the depth to the basement. It's around 5 meters, and then the depth to the shallow sources is around this, and this is the average depth is this, and this average depth of the shallow sources, because the SPI, like we said, is used to mostly exploit shallow sources, and the range of the value we have seen is fall within this range. So that means there's actually agreement. You need to remember this an average. The next thing you have to do is to, of course, you can edit this one. If you double click, anything here you can edit. You can double click, you can change this name. You can double click, or any tier you see, you can be able to change it. Anything you can be able to change it, link power, anything you want to change. So when you are done, you just go to map, export, JPEG high quality, set it to around 450 if you like, and click on OK. JPEG high quality. You'll go to images, magnetic, then spectral plot. So this is what we have under the spectral plot. If we go to our images, go to magnetic. As you can see, we now have our spectral plot. So there's no need to export this one to ArcGis. So this is a depth to shallow sources, depth to deeper sources, and this is what we have under the spectral, and this depth fall within that of the SPI. You have seen file project save, the window close on. Now into these maps, they can go back to the SPI now. Now this is how we able to do that of yes, we are able to do on the SPI. So we're able to now do on the SPI, the spectral, the average depth of the shallow falls within the range of the depth. And also let's look at the Euler deconvolution. For the Euler, we need to have this Euler 3D. You can come here, G, load menu, you look for Euler. This is the one. When you click on it, you open it, it's going to show you. It has mostly the place you go is standard Euler. That's why it's better to do the SPI. The moment you do the SPI, you already get this grid, the X, the Y, the Z, there, which can make use of this. All you need to do is to come here and go to the standard Euler deconvolution. And so this one is good for you to use it and be able to calculate the depth. To get it in meters, you multiply it by 1,000. By 1,000 is what you're able to get. This the depth used for the estimation. So let's see what. So this how to carry out this. So anybody have question to ask? So please, is anybody have a question to ask? Please, any question? Let's see whether you have a question to ask. Oh, move ahead. Okay, so now we are able to see how to carry out the spectral. We are able to see how to get the depth to deeper sources, depth to shallow sources. Now we want to move ahead to do the Euler deconvolution. We'll come to Euler 3D. Make sure you have do the spectral first. You have done the SPI. So you have the dx, dy, dz, because that is what this one means. Process grids. When you click process this, it's going to give you these 3 grids. Of course, we already have them. Just come to standard Euler. Under standard Euler, this is what you see. Click on this question mark. You can see the theory of this potential field interpretation. So this is what you have. See it? So that's why you need derivative along x, the x, derivative along y, the y, derivative along z, the z. Then you have the field you make use of, and the x naught and the y naught and z naught is the location of the source. X, y is the position where the value of t is calculated. That is this, and the value of this n is the structural index. Since we are using magnetic, can do for contact, can look for silk or dike, can look for cylinder, but most of these we'll be looking at only the first 3 and see which one works better for the area. If you are doing gravity, okay, if you are using gravity, then you can be able to check the difference. 0, this, so you can go over this and rate, and then the window size is also up to be very important. For this one, we use it to estimate depth, so we have to take note to know. Then x offset is what it means is this difference between the source of the magnetic bodies and that of the point where the data was collected. That is the x offset and also y offset, the same thing. This is the error in estimating the depth. Then this is also the local uncertainty as percentage of solution depth. Okay, so mostly this is what mostly interested about. So let me close back. Then again, we need to have the window size, because the calculation will be done around windows by windows, and the size of the window should be very large so that we can able to capture the depth of that anomaly. To do that, we need to know the depth. The maximum value of this gives you a number of grid size. 10 mean the grid size of 10. From there, multiply this one by the size of the grid. That will give you the window size. For us to do this, let's go back to our residual. Right click, properties. We can see it's 250 by 250. Take calculator. We take calculator. We take 250. Right? Then if I multiply this one by the maximum, which is 20, you see how we're able to get 5,000. So if I divide that one by half, that means I can able to go up to 2.5. I can able to go up to 2.5 kilometers down. And that is the idea. The window size, you divide it by 2. So you're able to know the depth of investigation you want to look at. So if you want to go deeper, it's better you increase this size, like 400 or 500. Then you set this, that one will be at 20. So that's how you have to take note of. Here is 250 multiplied by 20. I have this, then divide that one by 2. I have 2,500. So if I go back here to my Euler, standard Euler, then let me first bring the magnetic or gravity grid, bring my residual. So after the residual, bring the dx. Place check, look for the x, scroll, look for the y, scroll, look for the z. Solution database. Now, we now do for Euler 1, when structural index is 1. Let's start with 1. Structural index is 1. Then, yeah, this is the depth of tolerance, that is it. We want to be the maximum of 50. Anything more than 50 is rejected. So this is by default. Yeah, the window size, yeah, we can leave at the maximum is maximum of 20. Maximum depth to accept, and that's like I said, 2,500. 2,500. The height, flight height for this data is an aeromagnetic data. It's an aeromagnetic data. So the flight height is 80 meters. Sometimes you can put 0 if you are doing ground base. Or if it's an aero, you have to get the flight height, but the flight height for this data is 80. So I use 80. Everything is okay. Let's see whether there's somebody have question. So is there anybody have question? So nobody have a question to ask. So let's see. No question to ask. Okay. So I hope everything is clear. So everything is okay. Everything is okay. So let's see whether everything is okay for us. Proceed. Yeah, now let's go. Now, here we have this, we have this, we have that. Here we'll click OK. So we're doing for structural index of 1, this equals to 1. When we do that, a database is going to be produce 1. Click OK. So this is database. We'll go back to Euler. Let's do another one. We'll change this one now to 2. We'll change this value to 2. Leave everything. And click OK. Then and lastly, go to Euler, standard Euler. Then this 0. Then the value of this is 0. Click OK. So let me start for one, which is a dike solution. Here we have, like I said, this x, y is the position where the magnetic field is calculated. X Euler is the location of the source. A depth estimate of this position is given by this. Right click 3 times, right click statistics. You can see the range of the depth is from 967 to 415. Okay, now this is the depth we have. Then window size, you can see what I'm talking about, the window size, which is 5,000. That is 20 times that 250. So it's able to estimate those depths, even though we put 2,500, but it's not even up to reach that point. So that means, you look at it, you see the maximum is this. So it's not even up to that one. Yes, but it's large enough so that you're able to capture it. And that's what we're talking about. So now the third value is the DZ. Click 3 times, you see the values. The maximum is 50 because we say the error is 15. Maximum is 15, and there's value around 3. Now, what you need to consider is this. If you decrease this error, the number of solutions will go down. You see, the number of items you have is 15,816. And that's what you need to remember, 15,816. And this is what you have. And that is the depth. So this one will offset max. This is used to plotting. This one indicate that this value, this first row, be plotted. If it is asterisk, it means it should not be plotted. So let's see, does anybody have question? So anybody have question? Now let's go back to what we have. To plot this one, what we need to do is to go back to Euler. We need to create a new map. While this data is database open, Euler 1, click on scan data. Click next, scale. Yeah, we'll call it Euler 1_1. Finish. Go back to Euler raw base map. Give it the right of 5, the left of 2. Next. Now this one we say no. Say Euler solutions SI equals to 1.0 map. Now, based on this, we'll go back to you. We first need to plot first and see whether there's a need for us to decrease this error. So the data's channel depth, of course. The max channel, we want to tell the program to plot, which values to use, to plot or not to plot, use max. Leave everything, then click OK. Let's see, it's going to plot them here. You can see this is what we have. So even though you see there are many, for some, if you see there are some values are so many, if you like, we can leave it like this. If you like, we can just decrease the percentage. So what we do, just press the delete key on the keyboard. That's gone. So click away. So go back to Euler 1. Then now we need to decrease this. So go to Euler solution list. And then we need to filter this one. Then which are to plot. So okay, now channels with result depth DZ. So this one we want to base on this filter. We usually the match channel is this. We want to tell the computer anything less than this, don't plot. We'll see 0. Anything less than 0, anything in which the error is less than 0, don't plot. If it is greater than 10, don't plot. That is, we want an error that is between 0 and 10. That's what we do. We append the max. Click OK. As you can see, this error is 14. That means it cannot be plotted. The same thing to this. But at this point, it can be plotted. So now we can go back to our Euler plot solution zone colored. So it's going to plot it here. Now you see this is what we have. This give an error of what? An error of this thing 10, an error of 10. So you can see the number of solution is not much. The solution is not much. So what we'll do, so that values is too small. So that's why we have less value. So the best way is to delete this one. Go back to this, delete it, go back, yes. Go back to Euler, standard Euler. We'll repeat it for 1. So this way is more better to go this way. Then click this. So we'll just use that of 15 is okay. Yeah, go to Euler, new map, scan data, next, scale, finish. Your base map, 5, 2, next, sorry, they are finished. Euler plot solution zone colored. Zone colored, so we have this. Then we have okay. Okay, so now it's plotting now. This is the point. The next is to bring the legend, then color legend bar. Then we have depth, we have this. I leave to 2 place of decimal. Location, click on this. So click on this, move this. So move this way up. And this is what we have. The next is to go to ArcGis MSD save. Euler images. Go backward, go to maps. Euler 1 we save. So let's save it here. So this is what we have. Let's window close all. So is there any question to ask? So any question? So is anybody have question to ask? Let's see. Does anybody have question to ask? Yeah, so let's now try to go back to this. Now we need to change the format. Now of plotting this. So what we're going to do now is to click on this, click on this, click on this, click on this, you press delete. Click on this, press delete. So we have this. Let's go to Euler, draw base map. See, we can change those to 6 to increase the size. Next, next, finish. So you can see we have increased the size. So now we are going to superimpose. I'm going to bring in the SPI. So for all, you need first to move this one outside. And let's go back to Euler. We're going to now go to, we have been using this. They'll jump to the set side, which is called colored range symbols. So this is what we're going to look at. We'll first open the database. Euler plot solution, colored range symbols. Make sure you open database, then classification channel, depth. We're going to classify. We can start with 5. Let me start with 5. You'll see the reason why. Then max channel is max. And click on ranges. The letter symbol size colors. What are the minimum? We're going to divide those range. We know the maximum is 900. We have 900, so I can say 200. Or I can say 250. Here I can put 500. 750. 1000 and above. So anything from 0 to 250, anything from this to this, anything from this to this, anything from this. That's why it's 5 range. So anything more than 1000, can give it a different color. I will go to symbols, pause the cycle, go to sizes, we'll leave the sizes, we'll go to colors. Now we have the first color. We can swap this one, the blue. I use it blue, let's see. Use blue, can use blue, then green. I use blue, green, blue, then green. After that, I use yellow, and red, and purple. So use it. Okay, everything is then plot. We have, so we have a plot. Things we have. Then we'll come back plot solution. Now color legend. So what we click. depth, plot. Now move this what to bring. To do is to bring. So this is the SPI. To do this, now go to map tools and values are somebody please tell us about the negative. So the negative are not used. They are rejected, even though they are there, they are being rejected. So it's only the positive values that is. So you have to take note place. Positive value is the one that been used. So now let's see how do we the two. We bring the SPI, we go to map tools, single grid. We bring can bring either the XPI this XY. Then we are going to apply shape. Then we click on this small sharp less current map. This is how we does this. So yeah, we can put it horizontal or vertical. Click it at vertical and then click paste. Okay, this is how we bring it. Then click now on this. Click on this, move it somewhere. So this project save. And let's first export this map. JPEG. Later we export that images, magnetic Euler 1. Let's open it and see the correlation between the two, whether the now you can see for me first its name. Click on this. Superimpose on the SPI map. So we are doing this one. Okay, so this is what we have. Then file, project, save, export, JPEG, images, magnetic, replace it, yes. Now let's open it and compare and construct. So compare and construct. We see the depth between 2 to 500 is green for those points, green. And we can see, we'll now try to look at the grid. You're seeing it here is this. You can see the kind of correlation that we are actually getting. That you are not see it properly. So let's see 750. So it's not that the SPI is being stretched. So if you look at the 250, if you look at this grid up to around this point, up to red, you see up to red is around 250 for the grid below. And this below, you look at the blue, you will be able to see it. And that of the yellow colors, right? If you look at the yellows, which are higher up, right? The yellow, which are higher up, is what you see that actually corresponds to where you have, you see those yellows taking on these purple colors. See where they correlate. If you look at those yellows, see them here. Really found across this area, together with the green. See yellow together with the green because the green is the second one. So we have 250 to 500. If you like, you can reduce the scale so that they look similar to this. And that is the way, I think, is to reduce the scale. Let's see. So I put 0 to 100 to 2. Let me see. So I put 0 to 150, 200, and the rest. And that's why it should have been more better that way sometimes so that we can. So in this case, you need to place on this, select on this, press delete key, press delete key, press delete key, and press delete key. Then the same thing here, we can go back to this. Sabana is still 5 ranges. Now we'll say 150. 200, 250, and take 250, 750, or 500, we can take 500, yeah. Anything more than 500, 250, something like this. 150, 200. I can go to 100, 200, 150, 500, I think, something like this. Symbol which we have done, sizes, colors, okay, plot. Okay, now we can able to see some of them. and then Euler plot solution color range symbol legend. Then locate. Okay. Click, then plot. Now let's move it up. So anything less than 100, is blue. Less blue. The green is between 100 to this. The yellow is between 150 to 50. The red is 250 to this. And that's what we have. Now let's bring in the SPI. Those current map. Okay. Plot. This is what we have. Yeah, click on this. So this is what we have. Then file, project, save, a map, export, images, magnetic, replace. Then this, click on this. So now this is what you can see. Now the red, anything red is from 250 down to this, which correspond. Then the green, 100 to 150, 100 to 150. The yellow, 150. So the blue, light blue, and the yellow, the blue and the yellow. So now this is what you now check and see how they able to correspond. Those points are actually higher up. We have also have the red, which falls with this. The red are corresponding to the pink and purple because these two range corresponding to this part of this. You can see around 250 around here, part of this to this point. You can see some of them correlating. So if you look down here on this part of the dike, you have green, you have blue, the rest being able to align perfectly around the blue of the other one. Okay, this is what we see. Because of that depth, we show here the green and the blue. The green and the blue, as you can see, out of the green and the blue, the green and the blue in between them. And we're in the form to form the lines. You can see some of them. So if you check very well, you're able to see correlation there. Actually, some correlation between them. The depth, that's what we get. These areas where you see very well, and some of these areas. So and this is a way out to mix the two. Euler solution superimpose on the SPI map. That's how to do for the one. With this, you can now go to ArcGis, come back and modify the ranges if you want to. Click on this. Now you put Euler, I call it SPI. Go to maps. So you save it to the different name. Rep 1 and try to see whether you can get that of 2. Then Windows, close all. Then now we'll do the same thing now for that of Euler 2. Click on this 3 times. Now the same thing, but the depth you see the maximum is 135. So we'll see which one is the best. So the minimum is this. This one go up to 1,000. Let's see whether there is any question. So let's see whether there is question to ask. So I hope all of you can hear me well. Let's see whether you can hear me well. So, okay, let me see whether there is question. If you ask a question to ask. Okay. I don't know whether somebody can hear me. Can you hear me all? Can you hear me? So that all of you are able to hear me. So the same thing we do for this one. This click, let's see, statistics was 2 to 15. Like you can just follow the same way. New map, scan data. Next, scale, changes 1 to 2. Finish. Euler, draw base map. Put it to 6, or put this to 2. Next. We have the next value. This is for 2. Finish. Go back to Euler. Zone color. Let's see first. Let's roughly plot and see. You see here, you see there are so many. So this is why we're now going to filter them. We're going to see which will give us the better results. Sometimes two work best. One. So if this is the case, so this value things like that many, so we can take 0 to 10 and see. So let's see whether all of you can hear me well. So now what we are going to do, let's try to delete this and try to reduce the values. Try to reduce the values. Let's go to the database. and go to Euler window results, window solution list, channel DZ, max, we need 0 to 10. Anything less than 10, 0, don't plot. Anything more than 10, you plot. Okay, so let's click OK. Now you see it has applied the max. Let's check how many marks we have. And the number of dummies, 3 and above 75. Okay, the value has been reduced. I'll go back to map, Euler, zone colored. Okay, I see the values. Yes. Okay, okay, let's see. Then plot solution color. So I see around 400. I put yellow to red, 300 to 500, 300, 500. Okay. 300, 500. We have blue, 300, 500. Yeah. Delete. This, delete. Go to this symbol. Okay. Ranges. Okay. Let's class this to 6. Ranges 200, 300, 500, 300, 300. Let's go back and change this one to 5. 4. Change this to 5. 300. 50. 200. 150. 150. 200. 300 and 500. Like this. Okay. Oh, we have this. Let's see. So here we can see in this one, after maps, Euler 2, and okay. So I hope all of you can hear me well. So let's see. Windows close all. So we go back to this. Yes, we go. Go to map tools, single grid, SPI, okay, current map, okay. So this is what we have. I click on this, bring it down. We have this, so map, uh, to reimpose on the SPI map. And then I'll go to map, export. AI2. What again as ArcMap. This one to two. Save. Okay. This is what we have file. Okay, it has been saved. So let's close all. So you can see, you can go to those maps, compare and construct. You can see SPI is all defined. Goes to around, it's red, there's yellow, goes to around 300, 200. But the yellow is 300, 500, around 300 to 500 is depth. What you are seeing, this red part touching actually this part, and that is a bigger depth. That red is around this, so we shows this part actually come in line with this part, which shows a good correlation. You can see them here. So this is how to go about doing the depth estimation. So that's how to do the depth estimation using Euler spectral analysis. Yeah, construct also, you try to look at to get the depth. They won't come to the lineament. We're also going to make use of the Euler to try to identify some of these features here, which will go in and some of them will be correlated well with other methods. Analysis, you can see them. Well, this one, prominently these ones, you see. Of course, we can bring this one more. Let's go back to our lineament, the geological lineament. We check, bring that of the Euler tool. So now we're going to bring, we're going to do now. We are going to actually bring those lineaments we got from the geology area, superimpose on this. Okay, and try to see where they are properly delineated. What I'm going to do, let me right click, toggle. Then I will move this part. Let me disable the SPI from here. I'll disable it. Let me go to map, import shape files. Click on this. Go to back, shape file, lineament. You can see it. Open. Do not import. Plot to current map. Then click OK. Of course, you can see some of them. Literally getting some of them. like these prominent ones. Some of them, there are some fault, and then they cut across some of the features needed. So this is one way of bringing them. We can also bring the other one. Same thing here. Sometimes it used to be very slow. So now what we're going to do, let's bring that map, Lineament map, import shape files. Lineament, do not import current maps. Of course, you can see some of them, some of the fault. Okay, so this is how you look at them, the later you export. And then before we do the structure analysis, which are going to bring here and add to these ones, try to some of these lineaments are actually surface. Only way we are dealing with subsurface. That's why, but there's some correlation actually. See, by the time we do the structure using other methods, try to see how some of these lines actually follow the pattern. Of course, this can be approximate. This can be approximate this. How we approximate this, approximate. This one can also approximate. Okay, if we of this, we bring it. So you can see, so that's how some of them we are getting. Yeah, so let's try to close all. Now I'm going to save it. And do close all. File, project, save. And that is the way. So anybody have a question to ask? Now let's see whether you have time, any time to. Whether you have time to ask question or not. So let's see. I think that's what we have for today. For this, so we look into structural analysis. a look into the 2D forward inverse modeling aspect of it and how to go about them. We'll look into this too and try to see experimental analysis pattern we're able to see and how to get them here. Tomorrow. Okay. Thank you all. We're going to stop here. Once more, thank you all for your time for this wonderful training. So we are going to stop here. Surely, do our best to come tomorrow. We look into the structural analysis. Also move into 2D forward and inverse modeling using Qgis. That we know many tools of how to use the kinetic data analysis, reductions with rotary pole, RTP, RTE. Tomorrow we'll do a lot of other analysis. So we have CSPI, Euler, spectral analysis, then now structural analysis and 2D forward and inverse modeling. And that is other aspect we are going to look at tomorrow. Thank you. See you tomorrow.